Alrighty, so let's get started with chapter 17. Okay, so these are the notes that we're going to go over in class. The first few things here are just a lot of vocabulary that you do need to be familiar with, because I know there's multiple choice questions on the AP exam and tests and quizzes that will ask you, for example, like what is a sampling distribution? So that's today's lesson, like a sampling distribution. You need to know the definition of a sampling distribution. And basically, here's a sampling distribution. It's something that is based on a fixed sample size from a fixed population that contains all possible values of that combination. Or in other words, here's a definition again. You have to just memorize it. A sampling distribution is all possible values for a given sample size for a fixed population. So for starters, that's just the first definition you need to know. You need to recognize that definition. A sampling distribution is the distribution of all possible values for a given sample size for a fixed population. So just know that first definition. The second definition that you need to know is what is a parameter. I'll just read it to you. A parameter is just a value that comes from an entire population. So anytime there are multiple choice questions that will ask you, like, what is a parameter? It's just a value that comes from an entire population. And then the next definition that you need to know is a statistic. A statistic is just a value that comes from a sample only. So make sure you know the difference between parameter and statistic. So again, the whole second semester of stats is going to be, we're going to be studying populations, like populations of high schoolers or populations of adults who have diabetes or whatever population. And those will be called parameters. However, like in statistics, you can't always like sample the entire population you want. So what we'll do is we're going to take samples from the populations that we're interested in. And when you take samples and measure those will be called statistics. So make sure you know those three definitions so far. Next, here's some formulas and some symbols that you need to recognize and be familiar with. All right. When it comes to the mean of a situation, so when we're talking about means, like the average salary or the average age or the average score, whatever mean, if you're talking about a parameter, so the entire population, you need to recognize this symbol. This is the Greek letter M. It's called mu. But if we're talking about just a sample from the population, so it's called, remember, sample is called a statistic, we're going to use this little X bar with it. And then finally, the last symbol you need to know is we're going to be doing sampling distributions, which remember, it is the distribution of all possible values for a given sample size for a fixed population. Memorize that. So if you're talking about a sampling distribution, this is the symbol that we're going to use. We're going to just put, I guess, both of those together. So just recognize that. So next, here's some more symbols that you need to recognize. If we're talking about a standard deviation, again, from the entire population, you're going to be using this Greek letter S called sigma. If we're talking about the standard deviation of just a sample, you're going to be using the letter S for your sample. And then finally, for the sampling distribution, you're going to be using this symbol right there put together. And finally, the last thing you'll need to know are these formulas. So the mean of the X bar, so remember, the mean of the sampling distributions will always equal to the mean of the population. Let me write that down in words because you need to know that. So mean of sampling distribution So that's this little mean of X bar. That's the mean of the sampling distributions. Always equals the mean of the population. Always equals the mean of population. So that's the first formula you'll have to memorize. The second formula you'll have to memorize is the standard deviation. So the standard deviation of the sampling distribution is equal to the standard deviation of the population divided by the square root of the sample size. Let me write that down too with words. So this little sigma X bar stands for the standard deviation of sampling distribution. So today we're learning about sampling distributions. So the standard deviation of your sampling distribution will equal the standard deviation of the population divided by the square root of your sample size. Okay. So far I've just talked a bunch about some vocabulary that you need to know, some symbols you need to recognize, and some formulas you have to know. So make sure you just read over this. Finally, the last thing you need to know for today, which is sampling distributions, is that these sampling distributions have some conditions that you need to check in order to do any problems. So I know for your first quiz in my class, there's going to be a free response, and I'm just going to ask you, like, what are the conditions for the sampling distributions? And here they are. You pretty much just have to write it. The entire second semester of stats is a lot of writing. So for those of you that hate writing, it's a lot of writing. So here we go. Here are the conditions for a sampling distribution. I'll just read them kind of quickly, and then we're going to actually apply them on an example. So when you're doing a sampling distribution, the three conditions that you have to check are, number one, the randomization condition. Number two, it's actually called a 10% condition. And number three, the large enough condition. So if you want to do a sampling distribution problem, you're going to have to check these three conditions. So I guess after all that talking, let's actually get into some math. So here goes. Example 1. This is a sampling distribution scenario, so let's read about it. Number 1. The mean room and board expenses per year at a four-year college is $5,850. I probably should update that. That's probably like, I don't know, 10 years old. You randomly select 9 four-year colleges. Assuming that the room and board expenses are normally distributed with the standard deviation of $1,125. So letter A, I want you to check the conditions for the sampling distributions of the mean of these colleges. So we're going to have to do these three conditions that I told you up here. So you will, on the first quiz, you will have to just type it up on the online, on the free response text box. So just type it up. Number 1. It's called the randomization condition. So basically, if you're working out one of these problems, you want to make sure that your sample that was selected was random. And the way you explain it, it says the data values must be randomly sampled. So you read the problem and see if it says that your sample was randomly selected. And it does say here, you randomly selected 9 four-year colleges. So I'm going to put, problem says we have a random sample of colleges. So that's the first condition. And on the AP exam, if you decide to take it, there's always at least one free response question that deals with these conditions. So that's the first one you would write, assuming the problem says we have a random sample of colleges. So that's the first one. The second condition that you'll always have to check for, and remember, you're only going to do this once on the quiz and test because it takes a while to type it up. The second condition is called it's called the independence assumption, but I just call it 10% condition. You could call it either one, but basically this 10% condition assumes that your values are independent of each other, so one item won't affect the other item. So I can read you what it says. The sample values must be independent. There's no really way to check to see if the observations are independent. However, when a sample is drawn without replacement, we can check this 10% condition. That just says your sample size that you selected must be no larger than 10% of the population. So what we're going to do is, let's go check our sample size. So our sample size is 9 because it says we selected 9 colleges. So I'm going to put n equals 9. So we just need to assume, or we know for sure that 9 colleges should be less than 10% of all the population of colleges in America. So we can just put you can put assume or I know, we know, or you can put I assume. We know that 9 colleges is less than 10% of like all colleges. Either in I'm assuming America. So 9 is pretty small, so we can just say 9 is less than 10% of the population. Or you can put I assume 9 colleges is less than 10% of the population. Okay, finally, the last condition that you have to check for these, and then we'll actually do some math. But like I said, the whole second semester of stats, about 50%, no, I think more than 50%, about 70% is just writing, and there's very little math. So the last condition, you have to have a sample that is large enough. So the large enough condition says, although the central limit theorem tells us that a normal model is useful when working with a sample means, it doesn't tell us how large. Okay, so basically, here's how we're going to do it. First, let me write it down. Large enough sample condition. Sample condition. Okay, so for this third one, there's actually a whole lesson that we need to do, or that you're going to have to do on your own about the large enough condition. It's the second worksheet on this, where'd it go? Okay, it's called the central limit theorem. So sometime today or before our next, or this weekend I guess, before our next class, I do need you guys to look at this chapter 17 central limit theorem and look at the answer key so that you can learn more about this large enough condition. So for today, we're just going to say the sample is large enough. The sample of 9 is large enough. Because the problem says normally distributed. Because the problem says normally distributed. So basically, here's like the lesson that you're going to do on your own with that PowerPoint. If a scenario says that you have a normal distribution, then any sample size is large enough. So if the scenario says you have a normal distribution, then any sample size is large enough. 5, 9, 30, 45, 3, anything is good. However, if the problem doesn't say that you have a normal distribution, that's when you'll need this thing called the central limit theorem, which just in conclusion just says if your sample is at least 30, then it will be large enough. And again, you'll just have to do the notes on your own for that central limit theorem. Okay, so finally, example 1, letter A, we're done. You have to check those 3 conditions, and on your quiz, you will have to type them up online, because your quiz will be in Schoology Online. And that's how you do the conditions for a sampling distribution. So let me pause for some questions. So now that we've done all the writing, now we actually get to do some computation. So we get to the math, which is, like I said, my favorite part. So now we're going to be doing finding probabilities using normal distributions. So hopefully you can recall like chapter 6, like normal CDF and all the normal distributions we used to do. So here goes. Letter B. What is the probability that a randomly selected college has a room and board of less than $6,180? So we learned that back in chapter 6. So let me remind you how I do it. I put P for probability that X is less than $6,180. So what this is going to involve is a normal CDF. But in case you forgot first semester, normal CDF, I'll remind you how to use it. Let me just wake up my calculator. So we did this back in chapter 6. You need a calculator so that you can find the normal CDF. You're going to have to type in a lower bound and the upper bound, and then you're going to have to type in the mean and the standard deviation. So my calculator is waking up. Both of them are asleep right now, so let's give them a minute. Okay, let's pause the video until the calculator is now that my calculator is alive, we can do this normal CDF situation here. So what we do is, let me go to the scratch pad. You need to go to Menu, Probability Distributions. So Menu 55, Menu Probability Distributions, and we're going to be doing the one that says Normal CDF. So click that. Okay, and then again, if you remember from chapter 6 last semester, if you're looking for X being less than $6,000, remember, if it helps, you can draw the normal curve that has a mean with the standard deviation. What was the mean? The mean was like 5,850. Okay, and the standard deviation was like 1,000 something. So anyway, so if you go to 6,180, I'm just eyeballing it right here, and you want to find the probability that X is less than 6,180, that means that you want to find the area to the left of 6,180. So here's how you'll do it. On your calculators, you would put the lower bound. So for this case, the lower bound should be like a negative infinity. The upper bound should be the 6,180. So that's what I'm going to use on my calculator. Lower bound, negative infinity. You don't type in actual infinity because it doesn't work. So just type in a negative big number. Upper bound, I just said it, 6,180. I just realized that when I'm recording, only the document cameras records, not the calculator. It's okay, it can be audio part. Alright, the mean of this whole situation, remember that the mean room and board expense is 5,850, and the standard deviation of this whole situation is 1,125. Okay, now press OK, and this is going to give you the area of the curve to the left of 6,180, or in other words, it's going to give you the probability that the room and board for a college is less than $6,000, 180. So basically, let me copy that on here. Okay, so you're supposed to still show your work, and this is, I guess, for the AP exam, because usually, remember, on my tests and quizzes, you're just going to like type in the answer or multiple choice selected. But if it is for response, here's the work you show. You would show this, type normal CDF, negative infinity to 6,180, and then remember the mean was 5,850 with a standard deviation of 1,125, and then I forgot what it was, like 0.6 something? No. What was it? Thank you. 0.615. Okay, and that's it. So that was just a reminder of last semester. So just make sure if you didn't do this last semester or if you forgot, make sure you go back and practice normal CDFs, and then that would be the answer. And usually for my test and quizzes, that's all I ask you to type in. Just type in the 0.61 or just follow directions. Okay, so now let's try to do another one. Letter C. See if you remember this. Letter C. What is the 95th percentile of the room and board expenses? Okay, again, if it helps, draw the normal curve with the mean and the standard deviation. And then another thing to remember is percentiles means like the area to the left. So I'm actually, here's what you're looking for. You're looking for like, what is this X value here? So that if you do the area to the left, that has to be 0.95. So see if you remember how to do that. I need you to find me like which expense would give you an area to the left that's 0.95, because that's how percentiles work. And the way you would do that, in case you forgot, we're not going to do normal CDF. We're going to do the inverse normal here. So we're going to be using something called the inverse normal. Alright, go find it on the calculator. Calculator. Remember that you guys all have access to this online software. Your teacher should have shared it with you, or hopefully you have your own graphing calculator. Alright, menu, probability, distributions. This time I need you to find the inverse normal one. Inverse normal. type in what it's asking. It's asking for the area. Again, since you want the 95th percentile, then go ahead and type in 0.95. The mean was 5,850. The standard deviation was 1125. Okay? Alright, so here's what this is saying. This is saying that if the expense is $7,700, then that would be in the 95th percentile. So that's what we're going to copy for our answer, and that's what we're going to copy for our work. So for our work, I'm just going to copy what I typed into the calculator. So if I ask you to show your work, you would just show this inverse normal of 0.95, comma, 5850, comma, 1125. That's what you would show for your work. But normally, remember, I don't really ask you to show work on your tests and quizzes, so all I need you to do is to type in the right answer. So the right answer was 7,700. And then since this is money, let's just round to 2 decimal places. And that would be the answer that you would type for this situation. I guess I can pause for. Alright, so that was everything so far. All these calculations should just been from last semester. Now, okay, now here we go to like a new calculation. Letter D. Letter D says, what is the probability that the mean room and board of 9 colleges is less than $6,180? So, okay, the only difference basically now for letter D versus the previous one that we did. Remember, the previous one that we did, we were just talking about one random college. So we did the one random college. Now I need you to find the same thing, but I need you to find it for 9 random colleges. So here's how you're going to do it. It's still a normal CDF. Less than 6,180. We're still going to do normal CDF. Okay. And let me draw you the, I guess if I draw it, it's still the same situation. Okay, let me draw it. Okay, let's do it. So when you're looking for less than 6,180, it's still the same drawing here. Your lower bound will still be negative infinity. So let's still type that. The upper bound will still be the 6,180. Okay, now here's the difference. For the mean and for the standard deviation, what you need to do now, you need to use it for the 9 colleges. So let me give you those formulas. Here they are. These formulas here are when you are given a sample that's greater than 1, I guess. So these are for sample sizes greater than 1. Sample sizes greater than 1. So let's use it now. Notice how the mean is still going to be the same as the population mean. So here for when I type in the mean, I'm still going to type in the 5,850. Okay, but there's got to be some difference because this is not going to be the same answer as A. It can't. So here's the difference. For the standard deviation, here's our standard deviation. For the standard deviation, notice how it's not going to be the exact same as the original standard deviation. The only thing you'll have to do is you'll have to take the standard deviation and divide it by the square root of the sample size. So basically right now, when I type in my calculations on the calculator, the standard deviation was 1,125, but then you're going to have to divide it by the square root of 9. So that's the only difference, and that's pretty much all of chapter 17. You need to know the difference between what we did on letter B, which was basically a sample size 1 because it was 1 college. And I mean, you can think of like we technically did divide this by the square root of 1, but not really. So 1 college versus having a sample of 9 colleges. So here it is. Okay, and that was pretty much all of chapter 17. So we're going to just keep practicing it. So let's actually find the answer with a menu, probability, distribution, back to a normal CDF, type in negative infinity, 6,180. The mean will always be the same. The 850, the The only thing that will ever change is the standard deviation. So because we have a sample greater than 1, we need to divide it by the square root of 9. Yeah, there you go. And there it is. So the answer would be 0.81. Just type that in. Oh, copy that. Yep, that's it. So that's going to equal to 0.8. 06. I don't know. It doesn't matter how you round. Just follow directions on the quiz to make sure you know how to round. So why don't you guys try by yourself? I want you to try E and F by yourselves. I'm going to give you about 5 minutes. I'm going to pause this recording to try letters E and F. In case you want to come back and watch the recording again, I'll have it posted for you guys in Schoology. So letter E, we got 0.98. Letter F, we got 6,305 with 92 cents. Hopefully you tried it and that's what you got. If not, let me know so I can help you. So then, that was it. That was chapter 17. So I guess let's try another example. Let's see if we can do this one. Example 2. It's the same stuff. Suppose the adult weight is normally distributed. So that's good news, because remember, if the situation is normally distributed, then for our conditions here, you can say it will be large enough because the problem says normally distributed. Anyway, adult weight is normally distributed with a mean of 175 pounds and a standard deviation of 25 pounds. An elevator in our building has a weight limit of 10 persons or 2,000 pounds. What is the probability that the 10 people who get on the elevator overload its weight limit? Make sure to check the conditions for the sampling distribution. Okay, so again, we have to do all that writing. Maybe we can summarize a little bit, but the first thing is the randomization condition. I don't think the problem explicitly uses the words randomly selected 10 people, so let's just assume we have a random sample of 10 people. Usually the problem will say random sample, but if it doesn't say it, then you can just put assume we have a random sample. And for the AP exam purposes, make sure you put like a random sample of what. A lot of people, maybe, I don't know if you're lazy with writing, they'll just put we have a random sample and that's it. But like I take points off because like random sample of apples, babies, cars, people, like what are we talking about? So please make sure you put random sample of 10 people or random sample of colleges or random sample of students, whatever. Be specific. Second thing, the 10% condition. I guess let's assume the sample of 10, the sample of 10 people is, I guess, less than 10% of the population. And when you're writing your conditions, or I guess typing them up, the words don't have to match like word for word. You just have to explain with your own words about the randomization. You have to explain about the 10%, and then you have to explain the large enough. Large enough. So remember, for that one, we need to figure out if your sample is large enough. And basically, I kind of gave you the summary already, but that's your homework for tonight. In order for something to be large enough, if the problem says normally distributed, then any sample is large enough. So I'm going to put sample of 10 is large enough. Sample of 10 is large enough. Okay. Because problem says normal distribution. Problem says normally distributed. Distributed. Remember, if the problem doesn't have the words normally distributed, then 10 would not be large enough, and you would say the condition is not met, so we're not going to move forward. However, if your sample is at least 30, then it won't matter if it doesn't say normally distributed. Okay, so I checked the conditions. Now we actually need to do the math. what's the question say? What's the probability that the 10 people will overload the weight limit? Okay, there's two ways to do this. We can do this in terms of total weight, like 2,000 pounds, and find like the total weight of the 10 people, or we can do it with an average. So if the weight limit is 2,000 pounds and we have 10 people, that means that like on average, each person can weigh, you would take 2,000 divided by the 10 people, so that's 200 pounds. So this is one way to do it. We can find out that on average, if each of the 10 people weighs 2,000 pounds, then they would be right there at the weight limit. So I'm going to do it with this on average thing. So this question says, what are the chances that it will overload? So if each person weighs more than 200 pounds, so again, if each of the 10 people weigh more than 200 pounds, then they're gonna overload the weight limit, because they're gonna be more than 2,000 pounds among the 10 of them. So then I'm just gonna do my normal CDF thing, normal CDF, and the lower bound here is 200. The upper bound is infinity. Now we need like what is the average weight of American adult, I guess, with the standard deviation. According to this, the adult weight is 175. Okay, now be careful with the standard deviation. A lot of kids forget, like they'll leave it as 25, which is not correct, because we had 10 people in this situation. You have to divide by the sample size that you are talking about. So we're talking about this weight is for the 10 people. So now if you do that, then you can get the right answer. It's a very small number, according to the answer key. Let's do it real quick again. Probability distributions. CDF. 25 divided by the square root of 10. Okay. Yeah, so a very, very tiny number. Where do I go? So 0.00. Was it 3 zeros or 4 zeros? Thank you. And then a 7, right? Yeah. 8, 7, 8. Okay, so that was one way to do this specific scenario, and then you could have done it slightly different, and I'll show you in a minute if you care, but that's one way to do it, and that's chapter 17 that you guys need to be familiar with. So let me pause the recording. I don't even know if I was still recording. I wasn't even recording for this one, was I? Yes, I am. Oh, let's stop the recording.